Welcome to the final installment in learning how to use the Tanium PowerShell Security content. In this final installment, we're going to look at how to integrate with the other Tanium modules for Connect to send alerts to the security team, threat response to actually investigate the context around that malicious activity that was discovered through the PowerShell content. So what we've covered so far in these videos was the left half of the diagram here, where we've looked at the PowerShell sensors, the packages that we use to set up the environment, to deploy the policies, to harden it, and then to search for those malicious keywords. We've looked at that so far. Now we're going to look at taking that same saved question that we saw on the dashboard, sending that into Connect so you can get alerts, so you can know when the malicious commands were used in your environment. And then we're also going to look at threat response. For live response, pulling those files off the endpoint for analysis off box, and then live connecting and doing live file system browsing to see the activity around that incident and what caused it and what actions it took. So starting off in Connect, we've already got a connection created here. I'm just going to walk through showing you how to set one up. So we see we've got a PowerShell Security Alerts connection that was built. It's not been run yet. I just created it here in the lab. So we've created a security alert called PowerShell Security Alerts. And we see that over here it's enabled. And then we've set it up to be a saved question as the source. And that saved question is called PowerShell Forensics by Endpoint. And that's the one that we viewed earlier in the dashboard. And it's going to be targeting our PowerShell v5 computer group. And we're also going to flatten those results if in case there's multiple rows per endpoint so that it'll look nice in a CSV file. And then over here, we've chosen a file destination. Just give it a name, the file name, give it the date timestamp. In this case, we're just using a file for the demonstration purposes. Most likely here, though, you would choose whatever alerting security tool that you have at your disposal, whether that's Splunk or QRadar or some other type of tool there that you use to receive your alerts. And then down here, we created a filter for new items so that it will only send, so it will not send recurring instances of the same data, right? So if I've already detected it, I don't need to alert on it again. So that's the new item suppression. And we want to continue learning, setting that at 0 days. And this is kind of special here. You want to make sure you only check the first 2 columns for that index, because those are the unique columns that will be used to determine if it's a new activity or not. So we just want to look at those first 2 columns. We don't need the others. And then down here we have a format of CSV for that output. We're going to include the headers, and we're not going to tweak the columns or anything like that. And then we want to run this multiple runs per day, every hour on the hour as a suggestion. So what that means is we're deploying the search command history on an interval of every hour to the endpoint with a distribute over 30 minutes. And then our saved question runs on the hour to see if there's been any activity. And then we're running this alert to check every hour. So what that equates to is that somewhere between 0 and 3 hours you will get an alert, depending on the timing of those 3 1-hour intervals, right? So you will get an alert somewhere within a few hours. It could be a few minutes, just depending on how the timing plays out. But that's the way it stands today. You'll get that alert. So you get an alert, and you need to know, well, what was the problem? So you come in here to your PowerShell Security Forensics dashboard, and you can see the summary. There's our invoke Mimikatz we saw earlier, but we really want to go down here by endpoint because we've already received an alert that this was the endpoint with the problem. Now, prior to doing this, we're going to, in just a second, we're going to deploy an action against this endpoint to retrieve the data, but before we do, we need to set that up. So over here in threat response, we've gone into the Tanium threat response module under management live response. We've gone to collections and we created a custom collection for PowerShell Security. Now we already have a destination for, in this case, right here, we've already got an SMB share set up to receive the data. But under here, we're telling it what to collect off that endpoint as an ad hoc collector. And what I want you to see, and you might want to screenshot this so that you can go back and recreate it in your own environment. But what we've done is we've told live response, remember what it does is it'll go retrieve sets of files from the endpoint. So we want it to retrieve these things. We want it to retrieve that PS read line history under the user's app data path. We want it to retrieve all the PS transcript files that are recording the text file activity. And this is really important here. We want to record the Tanium client tools search PS directory, whether that's a 64-bit or a 32-bit Tanium client endpoint. Where it's installed. And what that does is that gives us the actual search results and some verbosity that we can't see in the console. It's going to show us a little bit of the context of where that command, it'll tell us which transcript file it occurred in, that kind of thing. And then down here we also want to grab the Windows event logs, but only those Windows event logs that have PowerShell in the name, WinRM, Defender. Those are the logs of interest for us in a PowerShell investigation. So we've set up this live response file collector here, this ad hoc collector. Now what that enables us to do is to go back over here for this endpoint, and we're going to deploy the action to find out what happened with this invoke Mimikatz. So we're going to deploy the action here called live response. You'll notice there's multiple live response packages potentially in your environment. We're specifically looking for the one called threat response. If you've not upgraded to threat response yet, you can still use the legacy live response Windows that requires a custom JSON, custom collection file, and you can reach out to your TAM to get that if you have the legacy form. But we're going to use the new live response package for Windows. We've defined our PowerShell Security file collector, and we've defined our SMB transfer location. When you deploy this package, it will take a few minutes to collect. I've already done that to save us some time. So let's go take a look at what happens. When you deploy that collection, it's going to come up on your SMB share, wherever that is. It should be configured according to the documentation so that it is secret, and the clients can only write into that share. So here I can drill in. I can look through the logs and see exactly what was collected, but we'll just drill right on into the file path here. And here you can see all the files that were retrieved from that endpoint for forensic analysis now. This is the rich data that you expect from Tanium. So here we can see the event IDs 800, 4103, 4104, and then just an all file that's a summary of all those. These are the files that are used by the sensors. Also notice PS readline and transcript. So if I open up the transcript file, for example, it'll say, hey, in the transcripts, these are the patterns that matched. Invoke Mimikatz, set wallpaper. But notice here, there's a .raw file for each one of these. And these are not by default mapped to Notepad or an editor, so you'll want to open with Notepad, and then OK. Now we can see inside this file, this is where we can see, okay, here's the set wallpaper command that was launched by, in this case, some type of an Amazon AWS script when the VM was provisioned. But notice here, there's our invoke Mimikatz command in context. It tells us that it found it in this transcript file. So if we want to see what was going on at the time that command ran, we need to go look at this transcript file with this unique string capital YURA1YM in that. And so that's the transcript file that we're looking for now to see the broader context of what happened. So let's scroll down. You'll see here are all the transcript files. There's also the interactive PS readline command history here, but notice this is the name of the transcript file that we were looking for. So if I open that up, and this is the process ID. You want to make note of this later, because when we do the live connection to the endpoint, you want to be able to filter by this process ID to see everything else that is touched, what was the parent process, child process, and so forth. And sure enough, there is our command invoke Mimikatz. Now in this case, we know this was a harmless demo. Invoke Mimikatz was not installed on the box, and matter of fact, we actually see the errors that it couldn't find invoke Mimikatz to execute it. That's a good thing. So in this case, that's all we have. In a real incident, you would then see the other commands in context around that invoke Mimikatz or whatever the malicious command was. So let's remember 3880 was the process ID. While we're here, a few other things we can look at. There's the student 1 and the administrator separate user profiles. And we look in here, we can see the commands that they typed explicitly at the command line. And we can see that somebody actually typed invoke Mimikatz. Usually you wouldn't find that here because it's going to be running in a background process. Also notice we have these EVTX Windows event logs. I can simply double click to open any one of these, and it will open it up in the Windows event log viewer. And it does take it a minute to open those up, and especially if these are large files, if we've set the event log size to 1 gig, that may take a little bit to open and expand. But once we're inside there, you'll be able to view in this particular log the 4103 and 4104 events that are logged. And there we are. I believe it's going to be down here. Yes, as a saved log at the bottom. We were previously looking at the other logs. So this is the saved activity that we can see from that endpoint now. And now we can browse through and look at those events and see what was running in the 4103s and the 4104s. And we can use the find command here. You can also simply mount these with PowerShell. There's a way to use the get when event commandlet in PowerShell to mount that and search it directly from the command line as well. Just one thing to note there is if you're using PowerShell to do PowerShell forensic analysis, you're likely to be searching for the malicious keywords using PowerShell, which means you're introducing those malicious keywords into your own logs on your own machine. That's usually something that you have to contend with as an investigator, because you know that you may be contaminating your own machine in the act of doing the investigation. So just be careful with that. So here we have the rich details coming out of the endpoint. We can see all the transcripts. We can view anything that happened in PowerShell on that box. And remember that these files are bounded by the last 6 hours of activity on that machine. So we've looked at each of these. Remember, we found that PID 3880. Now we want to go back over here to Tanium, and we've gone into threat response. Now we're in live connect, and we'll see that we're going to connect to this client, client 01. So what's happened here is I had it queued up earlier, but it's timed out already. It's not a big deal. It'll take it just a second to reconnect. So what we're going to do now is we're going to connect to that endpoint and view the local trace or the Tanium recorder database on that endpoint, which will contain all the details about every process, every network connection, every file activity, every registry key, anything that happened on that endpoint. We can search through every DNS lookup, you name it. We can go in with that PID, we'll go find it and see in the process tree what called that process and so forth. So we can click on this client then to launch that live connection. And now we're in, as they say in the movies. Now we're looking at these different types of activity. We remember that we found in the logs the PID equals 3880. And we're going to filter, and here we can see the PowerShell process that was running when that activity took place. We can see other activity in the background, conhost, WMIC, some other things that were launched by that particular PID. Double click to drill in. Now I can see what files were touched and what registries were touched, what processes, if there were network connectivity, and so forth. I can also use the process tree view here to see what was called, what called that one, and what else it called. I can look at the event history and see a detailed view of everything that was written there. So that's the full cycle of going from finding the activity, we set up the content, we got an alert that we found a malicious keyword in one of the PowerShell logs somewhere in the enterprise. We used Tanium to see which machine that was, which commands it was. Then we used live response to go pull those logs off the endpoint. Now we're using live connect to go into that endpoint. We can even save process evidence here. The other thing that we might want to do is while we're in this connection, we'll go back up here to client 01. We can also do browse file system. So this is new in threat response with live file browse. So here what we're going to do is we can now go into this machine as local system, and notice there's the PS transcript directory. We could browse through the user's path to find the PS readline history. We could go under Windows to pull the event logs. But the nice thing about this is, let's say you've got a slow link and you don't want to pull back gigs of log files. Now I can selectively hand pick files that I want to transfer off that endpoint. So then we remember the file name that we found earlier. If we can scroll to it here, there it is right there. So we can download that file. Are you sure? So I can pull just that one file off the endpoint, and now it's requested that file to be transferred, and we can see the saved evidence up here, the files. There's that file. We can click on it. We download that file, and that file is encrypted with the password of infected. We won't bother to view that file because we've already viewed the contents earlier in the live response capture. So that's another possibility you have to selectively pull files off that endpoint. You could even pull them out of the Tanium client directory in that path that we viewed earlier, where we had the Tanium package files that were generated for output. So there we go. Let's go back here to interact now. So we've looked at the PowerShell security content for Tanium, the end-to-end forensics workflow of what it looks like to find malicious PowerShell keywords in the enterprise, then to investigate them. If you have any questions about this process, how to get the content, any issues at all, you can reach out to your TAM. They would be happy to help.